Hello friends, welcome to next tutorial in ChatGPT RPA series. In this blog, we'll demo the process of updating mouse columns across numerous files with a significant amount of data. Below in video description, you'll find links to GitHub source code and YouTube playlists. So let's browse to our GitHub RPA repository. Inside this repo, if you're looking for other Python automation code, you'll find links to a lot of different examples which perform variety of different tasks. In today's blog, our main emphasis will be on conducting extensive calculation on large-scale datasets. So let's get started. You'll find link to this Jupyter notebook in video description below. Now, we are going to discuss few Python functions which perform simple addition, subtraction, and multiplication. I assume you're already familiar with simple Python code, so I'm not going to write this code again. However, if you are a developer and you have been asked to write some custom calculations which involve some very complex data transformation, then you have to write it from the scratch. So let's take an example here. Let's import pandas as PD and we are going to read a CSV file into a data frame. As you can see in this dataset, there are three different types of interest calculation method: buddy deposit or a simple deposit, certificate deposit or compound deposit, and mutual fund. Now assume an investor expects returns on his investment. In this example, you see different calculation based on different calculation types. So for example, simple interest, mutual fund, or a compound interest. Now you expect different ROI methods based on different return types. Now let's assume these are the formulas which help you calculate interest rate depending on the investment. Now these calculations on dataset may seem very straightforward, but think about a banker who deals with datasets which include more than 1 million transactions daily across thousands of branches over a period of time. Now in this case, the simple calculation will take hours on this much amount of the data. This is the problem we are going to address, and we are going to write code to perform this mass calculation. Now we'll have few options. As you can see, we can use the pandas or we can use PyArrows or Polars to address or perform this kind of mass calculations. Here are the steps we are going to take to perform mass calculations. First, we'll define classes, data structure, custom transformation methods using object-oriented methodology. In this section today, we'll use Python Pandas data frame library to perform these calculations. And next follow-up blocks, we'll do the same transformation using PyArrow followed by Rust Polars data frame. Let's import random here. And then we'll begin by defining a data class called deposit. Now this deposit data class is going to define the data structure and methods to do calculations. So let's initialize this class. And as you can see, what is actually a deposit? A deposit is a combination of all the data elements like principal amount, return on investment, etc., etc. So for example, deposit, amount. So in this deposit class, we want to have all of these data types. So let's go initialize this one by one at a time. So as you can see, once you create an instance of deposit class, you expect a couple of things to pass. So for example, principal amount, compound, rate, and time. And we are going to initialize those. So self.principal amount equals to P, whatever amount is passed. Same thing goes with the rate. Self.rate equals to, we'll divide it by 100 because rate is mostly represented in terms of percentage. Self.compound is a compound frequency. In simple interest, if it's a yearly compound, is always 1, and it always depends. For monthly is 12, for daily is 365. Same thing with time, because the time is passed in the number of months, so we are going to convert those to number of years. All right, now let's go define methods which do the calculations. So simple B deposit or simple interest deposit. So if you recall, the formula to calculate the simple interest is this: principal amount, and then 1 plus R times T, rate times T, divided by compound frequency. All right. Now, whenever this function is called, we want to return two different values, interest and total. Basically, they are the same thing. Total is equal to principal plus interest. So all we are going to do, we are going to code that formula what we just saw. P in bracket 1 times R times T divided by N. 1 plus R times T divided by N. All right. So self.principal amount and then multiplied by inside the bracket 1 plus self.rate times self.time divided by self.compound minus self.principal amount. Right? Because we are returning two different things, interest and the total. You can always return one thing depending on your requirement. All right, and we are going to round it up, and we are going to limit the decimals to last 2 points. So this looks pretty good. All right, same thing, just like the fixed deposit, we are going to code the second function to calculate the certificate deposit or the compound interest deposit. As you can see, compound interest deposit is a little bit more complex. It's not that complex, it's a little bit different. It says like principal amount 1 plus r divided by n to the power n times t. So just like the previous function, we are going to simply code this formula. So return self.principal amount multiplied by inside the bracket 1 plus self.rate divided by self.compound and to the power self.compound multiplied by self.time. And they are going to return two different things, interest and the total. All right, now let's code for the third deposit types, which is mutual fund. Unfortunately, we don't even know what mutual fund formula is. Nobody knows. So this is the reason. See, he says okay, that means God only knows. If you know that, it's definitely you can code it along here, but we don't know. So what we are going to do, that's the reason we have imported the random library here. So random, and we are going to return a random value here. And of course, we don't want to return anything like, absurd. So we are going to return something which is like, 0 to 50%, something like this. All right. So this is the formula for random. Now, all we need to do, we need to create a wrapper function which can call any of these functions. So depending on the deposit types. So for example, if deposit equals to CD, then I want to call certificate deposit methods. And of course, here I'm going to pass some default values here in case a user forgot to pass compound interest or default values there. All right. So here, let's go call this function here. So what this function does basically is a wrapper function, and it just instantiate. It create a new object of the deposit class, and so that calculations becomes very easy. All right. And then depending on the deposit types, it simply call that particular method from the deposit class. All right. And that's else statement. So if deposit type equals to CD, then call the CD method. If deposit type equals to body or simple interest, then call the appropriate method. Otherwise, by default, is going to create a mutual fund. Now all my data structure method object oriented programming interface is ready. So all we need to do, we need to make use of this formula. So we are going to call this wrapper function get interest method, and we are going to pass the default values here. See, as you can see, it becomes very, very easy, and it understands what interest methods calculation has to be called. Now, all we need to do, we need to go back to the data frame what we have read into the pandas data frame, and then simply call this function row by row. Now we are ready to use this function inside pandas data frame. As you recall earlier, I said I'm going to show you exactly how you can do the same thing using PyArrows and Polars, because as data becomes significantly large, you want to use some arrow-based or column-based methodology to do for data transformation. All right, so here again, as you can see, I'm going to read the data from simple.csv into a data frame. And here I'm displaying the top 10 rows. So for example, in this case, as you can see, interest and rate total have been already been calculated, but we want to verify that interest and total have been correctly calculated or not. So that's what I'm going to show you here. So very simply, all we need to do, I'm going to create inside the data frame, pandas data frame, I'm going to create a new column, and I will use an apply function on the data frame. And inside the apply function, I'm going to pass a lambda function again. So what it does is simply takes each row and it calls the get interest method what we have created earlier. And here all I'm going to do for each row.deposit, whatever in that row, I'm going to take those values from the row like deposit, amount, compound, ROI and time, and I'm going to pass all those values, and I will call the functions what we have created row by row. And that's what actually df.apply function does. All right, it's one line, simply one line can do all the calculation for you. So let me execute this. As you can see, there is already a column there, and here you can just verify. That's how you, for example, you have been given a task to do reconcile the data. So see, that's how you can verify the calculation which you have done are done correctly or not. As you can see, mostly the calculation related to certificate deposit or simple deposit has been calculated correctly. In case of mutual fund, of course, because we use a random value, it's not going to match. But that's how you perform the data transformation task. Again, this approach is a very, very simple approach. If you have a simple data set, very limited data set, pandas do a fairly good job. And in next videos, I'm going to show you if the data becomes bulky, then how you can address that problem. But again, pandas is not that bad, especially after pandas 2.0 version. It is you can use it for data transformation. It does a pretty good job up to GBs of the data. So for example, I have tested this using on 1 billion rows. So and you can use this code. Again, you can find this notebook in video description below. This particular code will help you benchmark performance statistics. So that's all I had to cover in this blog today. And in follow-up videos, I'll show you how you can use PyArrow and Rust Polars data frame to do the same data transformation. Thanks for watching. Stay tuned. Thank you.